Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we are going to discuss about reliability design, and this topic you will find in third unit as topic number 11. So from this video we are going to learn three things. The one is what is reliability design. The second is I'll be taking some example to make you to understand what is the problem. And the third is we'll find the solution for this problem using dynamic programming, and we'll use sets method, and this method we were used in knapsack problem. So that method I'm going to use to find the solution for reliability design problem. Now let's get started. So what is reliability design problem? So as I told you in the before slide, in this section we look at an example of how to use dynamic programming to solve a problem with a multiplicative optimization function. So the exact problem is what? I wanted to design a system that is composed of several devices connected in series. So to understand this, I'll give a sample example. Let us assume that I wanted to conduct a seminar in a classroom. Conducted classroom seminar. Now, when this is my task, now what are the things I look for? One, classroom. The other one is one projector. The third is benches. The fourth is availability of board. Fifth is markers. So all these are the things what I need. In other sense, I'm calling these are devices. These are the devices what I need to run my task. Now, so here the reliability is matters. What is the reliability? Each device is having a reliability. That is this classroom and projector, board. Each device is having a reliability. What is the reliability? Reliability is what is the probability of working good. If I am taking some X object, if I am talking about the reliability of this X, what do you mean by X? The probability of this working good. Now, assume that the supposed reliability is 0.9. That means it is good. The working condition of this object is 0.9. That means 90%. So, the 10% is there, no? The 10% is what? Failure case. Now, let us assume that I have taken these devices. So, D1, D2, D3 up to Dn. You can have number of devices. Now, when I depend upon these devices to run any of my tasks, concerned to the reliability perspective, I cannot give the guarantee that how long this will run. Correct? Now, what I will do is, I will be going to increase the reliability of these devices. How I will be going to increase the reliability? That by taking multiple devices. Now, multiple devices connected in parallel in each stage. That means stage 1, stage 2, stage 3, stage n. So in earlier case, we were dependent upon only one device. If this devices get failed, yes, for sure there are possibilities that this device cannot be run for long time. If it is failed, then the system what I wanted to build will get failed. That is the reason why we will be having multiple devices. Now, in stage 1, instead of taking one device, I am taking some other devices. So, these are what the other devices what are required in D2 stage as well as in D3 stage and Dn stage. So, to improve the reliability, we should have multiple copies of the devices. Now, we'll be calculating the reliability of the stage. Probability of working good is R1, reliability. R1 is equal to 0.9. So 1 minus R1, that reliability, not working good condition. That is 1 minus 0.9, which is 0.1. So this is what working good, reliability, and this is what not failure case, not working good. Now, it is for only a single copy, but I am telling you that we will not use a single copy. Respective to the reliability issue, we'll make use of multiple copies. So half the way I have to calculate multiple copies reliability, that we'll see now. So how I will calculate is 1 minus R1 whole cube. This cube is what? That a device is having 3 copies. That means I am calculating for D1. As you can see that D1 is having 3 copies. Now 1 minus R1 whole cube is equal to 0.1 whole cube is equal to 0.001. So 1 minus R1 whole cube is equal to 0.999 is the working condition. So it means that if I have multiple copies of the same device, then the reliability of the entire system may increase, and we want maximum reliability. So for that I should have the extra amount with me, that extra capital buying multiple copies. So now the actual problem is, if I have some cost. Now this is what I am talking about, the cost. We were discussed about this, right? This what devices. Now these are the devices. For each device there is a respective cost. If I wanted to give a multiple copies to each device, then we have to buy it, correct? That means you have to spend some cost. If D1 cost is 31, if I wanted to take the other copy of D1, cost will be double, that means 60. So if I wanted to take third copy, then cost will be 90. So to make this is, we were given with a problem. Now this problem I have taken from the textbook. Now this problem is what? There are some devices and there are some respective cost and respective reliabilities, and this UI is what? The number of copies what are required, the number of copies what are required to increase the reliability. So this I have to find out. So how I can find out is, we were given with a total cost which is 105. So the total cost of the given devices is sum of Ci is equal to C1 plus C2 plus C3. That means C1 is 30, C2 is 15, C3 is 20. Total 65 is the cost. Total 65 is the cost, correct? So still I can have other devices to be buy. So other devices what I can buy, that also we will see with this formula. Now this formula is what? Now C minus sum of Ci. So C is what? The total cost, which is 105 minus 65 is equal to 40. So this $40, I'm just assuming in the form of dollar. So total cost is 105. Already $65 I have spent for these devices to produce the high reliability, good reliability. I'm buying the multiple copies of it. So how much cost, how much amount I have? $40. So I should spend this $40 of amount to purchase the other devices. Now, so let's see what devices we are going to have multiple copies. So to know that, so I am just taking the formula which is C minus sum of Ci by Ci plus 1. That means 40 by, this is what? 105 minus 65. We got here 40. So I am taking directly 40 by 30. Ci is 30 because I am calculating for D1. How many multiple copies are required for D1? For D1 I am calculating. So 40 by 30, I am taking a floor value. So that is 1 plus 1 is equal to 2. So D1 is required 2 copies, 2 multiple copies are required. Now let's check for D2. D2 is what? 40 by 15 plus 1. So you will get here 3, right? Now 3 multiple copies are required. The next is D3. D3 value is what? 40 by 20. 20 plus 1. That again it is also required 3. So total multiple copies what you required is 2, 3 and 3. D1 is, you can take D1 2 multiple copies, D2 3 multiple copies, D3 3 multiple copies. Now this is not the solution. We have to take the sequence of decisions, because this is a optimization problem where I am applying dynamic programming. So dynamic programming is what? It is an optimization problem, and we will be applying the sequence of decisions. Based upon these decisions, we will be going to know which copy is going to be included into the reliability. That means I can take 2, 3, 3 maximum, but if you take the cost of it, it will go beyond of 105, but you have only $40 of amount. Did you understand? 2 in the sense what? So one more 30 has to be spent, 30, and already one device is here. 2 devices, cost will be again 30, and here you have already one device and 2 more devices, 40. So total cost is what? 40, 30, 30. That means 100, but you have only 40 rupees or $40. So the point is what? How many copies we are going to take into the solution. So that will implement through sets method. Now the problem is starts now here using sets method. So how the way I'm going to move is, if you can remember the first knapsack problem solution, it will be very easy for you to understand the same. Now, order pair relating to the cost. Order pair is what? R comma C. Reliability and cost. Now, ES0, first set. 1 comma 0. So that means I can take here 0 as we were taken in the knapsack problem. We can take here 0, but I am not going to take 0. If I take 0, because I am going to calculate this reliability, I have to multiply. If I took here 0, what happens? 0 into something, it becomes 0. That is the reason I am taking it as 1. Okay. Now I am considering the first device. The first device. So 2 copies I have possibility, 2 copies. Now let's see, if I take first copy, if I take 1 copy, then S1 is equal to, what is R, reliability factor of first copy? 0.9, these are points. 0.9 into 1, that is 0.9, comma. Next is what? The cost of this. The cost of, what is the cost of 0.9? D1 cost is 30. So directly write here 30. Now next. So this is for single copy. But I have a provision of taking 2 copies. Now include second copy. So if you wanted to include second copy, that S1, S2, 1. Second copy of first set. That means I should know reliability factor and I should know cost. So reliability I have to calculate with the formula. That the formula is what? 1 minus R whole square. This 2 represents that you are going to take 2 copies, is equal to 1 minus 0.9 whole square, 1 minus 0.1 whole square, 1 minus 0.01, you got 0.99. Now, so this 0.99 I am writing over here, 0.99 and 2 copies, right? So 2 copies in the sense 30 plus 30, it is 60. So with this we were completed first copy and the second copy. First copy and the second copy we completed. Now S1, that is first device with 2 copies, is merged. 0.9 comma 30, 0.99 comma 60. So this is what S1. Likewise, we need to take a decision in the next stage, taking the value of S2. S2 is what? We'll just take S2 in the same way. Now come here. Consider the second device. Consider the second device. So second device is what? 3 copies. So now I am taking the first copy. RI, reliability value is 0.9. Now we have to multiply this with 0.9. Why? Because I am going to take D1. We already had D1 in our reliability problem, and now I am including D2. So we will multiply this. 0.9 is D1, 0.8 is D2. We have to multiply this. Now S12 is equal to 0.8 into 0.9 is what? 0.72, comma 30 plus 15. 30 is this cost, 15 is this cost. It becomes 45, comma 0.792, comma 75. This is what? S1. S1 with single copy. Now we should even calculate S1 with second copy, correct? Now reliability of second device for 2 more copies you have to calculate. You should know the value of S1 with 3. So S1 with 3 means what? S1 set, that means taking of second device with 3 copies. If you wanted to go for it, you should know reliability factor. Reliability formula is what? 1 minus Ri whole square. That means 1 minus Ri value is 0.8. 0.8 whole square. 1 minus 0.2 whole square. 1 minus 0.04. 0.96. So the cost is 30 and the value is 0.96. Now S1 3 I am going to write with the second S1 with this is what? 1 set and this is what? Second copy. For the second copy I am taking the value 0.9 into 0.96 comma 60 and 0.96 into 0.99 comma 90. Now so this value is 0.864 and this value is 0.9504. So it is what? 90 we got, right? So 90 in the sense what? I have cost, the availability cost what I can utilize is 105. But here already I hit for 90 and we have one more device to buy. The one more device cost is it's 20. If I take here 90, only 15 rupees is left. $15 are left to buy this. So obviously this will not include into the solution, right? Now I am cutting it, I am ignoring it, I am deleting it. Now take that S1 of 3. That means third copy. So again calculate reliability factor. So when you calculate reliability factor, it gives you 0.992. Apply the same value. So apply the same value means what? Here it is cube because 3 copies. So if you apply cube here, now this value is what? 0.008. Now this value will be what? 0.992. So 3 copies means first copy cost is 15. If it is for 3 copies, then it would be 45. Now, so here you have to take S1 of 3. That means we will be going to take 0.9 into this time 0.992. 0.992 comma 75 is the cost. Now 0.99 into 0.992 comma 105. Again 105 you have to cut it because we have the other device which is already there in this problem. So $20 you have to keep in your hand. So here if you spend 105 over here, you can't get this item into your set solution. So obviously this is not required in the solution. Now write final S2 set. S2 set is what? You just merge S1 with single copy, S1 with double copy, S1 with 3 copies. You just merge the solution. That is what? 0.72 comma 45 will be in the set. And the next is what? This value 0.792 comma 75 and 0.864 comma 60 and 0.8928 comma 75. So with this we finished D2 with 3 copies and we still more to move for S3. The same way you have to calculate reliability factor for S3. So after you calculate even for S3, then the sets values are this. Now you have to focus more. When you got your S2 set, so now look at this. When I got S2 set, I have a look all these sets pairs of reliability and cost. Reliability is 0.72, cost is 45. Now second pair of thing is reliability has increased, proportional cost is also increased. Now look at this, reliability has increased but cost is decreased. And a very sensible question is what? Why the reason I am making my reliability should be high? That to make reliability high, I am spending my amount. If I am increasing it, if the cost is decreasing, then it is of not in a proper way. So according to dominance rule, you have to cut the higher cost where it occurs. So this is the higher cost. Now I am just cutting it. Now in S2 solution, we will not include this, and we'll write the S1 solution. Now look at this. So when you are getting S3 solutions, there are costs which will go beyond of the available limit. So when it is available limit, we will just cut it, exceeded the cost. Now with the 3 copies of S2 set, that means the third device inclusion with 3 copies, there also you will be getting these figures where it goes exceeds the cost. So we will cut even this. So finally S3 is equal to 0.36 comma 65, and these are the sets. Now, so which is the maximum cost? Your maximum is 105. So which is near to that? 100 is this figure is near to that. So now in which set it is included? Now in which set it is included? In this set it is included. That means D2, D3 is required, D2 is also required, D2 is required, correct? Now, so from which number it has came? Now if you go back, you will find in S2 set. Now that also I will show. S2 set 0.864 is the 0.864 is the base to generate that S3 value, right? Now from where we got this? From 0.930. So with this, what I wanted to conclude is, whichever values we were seeing now, that all the values were included in the solution. Now that are what? Reliability is 0.648 pi Ri, and the cost is 100, which is sum of Ci. Finally, D3 is required 2 copies, D2 is required 2 copies, D1 is required single copy, and this is what the solution for this problem. Okay, thank you all.